here I get to call the fire department, right? And I get to call the fire department, depends on my report. But I also get to this, and I have a first decision, so if there's two decisions. So first of all, I get to choose whether I check for smoke. And I check for smoke. The only information that's available to me is this report, is whether someone told me there's a report. I get to choose whether to check for smoke or not. Whether I see smoke depends on whether there is smoke and whether I check for smoke. And based on this, I have to decide whether to call the fire department. And the information that's available to me when I call the fire department is the report, whether I check for smoke and whether I see smoke. The utility depends on whether there's a fire and whether I call and whether I check for smoke. So there's a cost associated with checking for smoke. And then the utility otherwise depends on just both the fire and whether I check for smoke. Okay? Does that make sense about what we're doing here? So the arcs into this are what the utility depends on. The arcs into the call are these parents. So if we look at... So in here, if I load the sample problem, this is the fire alarm. Right. So if I look at this one, if I look at view probability and utility, actually, so if I look at the probability and utility, I have exactly the same values that I had before. Why doesn't it let me do that? Right, so if I have this fire, just the same one I had before. So this is exactly the same model we had before, except now we have see smoke is a function of, here I said if there is smoke and I check for smoke, then I see smoke, otherwise I don't. So this is just another random variable we did before. There's no tables associated with check smoke and call, but there's a table associated with utility that here tells me what the utility is, and here we just arbitrarily scaled it between the cost of it. I think if there's a fire and you don't call it, you lose 5,000, and checking for smoke, I think, costs 20 here. Okay, if you do call, so if you don't call and there's a fire, you end up losing lots of 5,000. Otherwise, checking for smoke is reasonably cheap. And if there's no fire and you call, then you lose 200. That's the story. Okay, any questions about that? Yes?
In this case, the utility is 0.
Here, all these models you're trying to maximize. So all I'm trying here, I want to maximize. The ideal situation would be there's a fire, I don't check for smoke, and I don't call, and everything's happy. There's no cost associated with me, nothing happens. The worst outcome here is that there's a fire, I check for smoke, but I didn't call, because I pay the cost of checking for smoke, but then I didn't call, then the house burns down. Right, and everything else is weighed between them. But it's just an arbitrary scale. People do all sorts of things. Okay, does that make sense of what this means? So when I check for smoke, okay. So in summary, there's 3 sorts of nodes. There's the random, the decision, and the utility. There's exactly one utility node. There's only one of these utility nodes. We're not... the random variables and decision nodes have ranges associated, and there's no variable associated corresponding to this utility node, right? There's no utility random variable. There's no utility variable. There's only variables for random and decision variables. There's a factor for each random variable representing the conditional probability of the variable given its parents. So this is the same as we had in the belief network. There's a probability of each variable given its parents. And there's one factor on utility that's the function of the parents of the utility. Okay, so that's the same as we had before. There are no initial factors for the decision nodes. Okay, There are no initial factors for the decision nodes. And, okay, any questions about that? All right. So let's, because we messed that one up, let's do this one. So here's the story. It goes, I've got a disease. So someone has a disease. And from the disease, the symptoms depend on the disease. I get based on the symptoms, I get to decide whether to do a test, or what test to give. Then the test results depend on the disease and the test, but not on the symptoms. Then I have to decide on treatment, but the treatment here depends on I get to observe the symptoms, the test, and the test results. Right? Then the outcome here of this depends on what disease the patient has and what a treatment I give. Right? It's independent of the test results and the symptoms. Test results and the symptoms, the outcome doesn't depend on that. It just depends on what disease you have and what treatment is given. And then the utility, there's some cost associated with the test, and otherwise it's a function of the outcome. Right? This is the story. So how many factors are there initially, and what are they? So how many factors are there initially? Okay, who can count? How many are there? I heard someone. Five. Any others? Okay, what are they? Yeah. The probability of symptoms and disease, right? That's all. What else is there? That's one of them. Right, the probability of disease. What else? Someone else, what else is there? So I heard outcome. What does it depend on? I can't hear it. My neck hurts too much. I can't see it. You have to tell me. Given treatment of disease. Treatment and disease. And what else is there? Probably a test result. Given test and disease. And someone else, what else is there? There's 1, 2, 3, 4, and you all agreed there was 5 because no one else said anything else. What's the other one? And what's it a function of? Outcome and test, right? Right, there are 5 of them. Everyone happy with that? So when does the agent observe the symptoms? When do you observe the symptoms? Oh. Yes, when you decide to test. Okay, there's 5 factors, right? You observe the symptoms before the test. So the agent observes the symptoms before the test. observes the symptoms before the test. Right, before it has to decide what test to do, you get to observe the symptoms. When does the agent get to observe the test results? So when does the agent get to observe the test results? And? Well, so the agent observes the test results after the test, and what else? Well, no, well, hang on. Well, you only get to make observations for decisions. So right here, in here, the decision variable, right, represents the information available to it. It gets of information available for decisions. Okay, so when does it get to observe the test results? Right, so the agent observes the test results before the treatment and after the test. So the agent observes the test results before the treatment and after the test. You can tell it's after the test because it's not a parent of test. Right? And we don't have cycles in this thing. We don't sort of get to see things that happen in the future. Does that make sense? Questions? Yes?
Does that symptoms also observe before treatment?
Yes, the symptoms of, yes, the test happens before the treatment. Yeah, so it happens, you observe the symptoms before the test, you do the test, and then you do the treatment. When does the agent observe the disease? So when does the agent observe the disease?
When it observes the test result.
So does it observe the disease when it observes the test result? So when does it observe the disease? Doesn't, right? It doesn't observe the disease. The agent never observes the disease. Which is pretty typical in these things, right? You only get to, the only thing it observes, it gets to observe symptoms and the test results, and then has to make a decision about what to do according to this model. Does that make sense about all these funny arcs mean in here? So this is the information that's available to this agent, so it doesn't get to observe the disease. And the only other question is, does test affect the outcome? So in here. Oh, we've run out of time. So the answer is that no, the testing here doesn't affect the outcome. Whatever tests you do here, it doesn't affect the outcome. It only affects the treatment. But given I do the same treatment, the outcome is going to be the same. The outcome doesn't depend on the test. We're not modeling an invasive test that might have bad side effects we're only modeling this sort of innocuous test that doesn't affect the outcome. That's what this model says. Okay? So we'll get used to it. We'll play with these models. That's what we're going to play with in the assignment, and this is this model. And they're reasonably straightforward once you understand them. Let's stop there.